Welcome everybody for next talk in the tech track. Now it's going to be Tom. He's the principal engineer at Doodle. He's been at Doodle for 6 years already and he likes all sorts of software engineering. And in this talk, he's going to tell us how he's going to create a modern web application without external code dependencies. So only web server, a browser, and a text editor. Hashtag use the platform and possibly also hashtag minimalism. So with this said, I pass it on to you, Tom.
Yeah, thank you very much. Welcome to my talk. My name is Tom. I'm working for Doodle, and today I want to talk to you about a fascinating topic that may interest experienced and beginning web developers, but maybe product development in general as well. Specifically to the question zero dependencies, a more sustainable way to create modern web applications. I'll try to explore this question with you together. Why zeros? Dependencies, you may ask. That is a very valid question, since the reasons why we are using dependencies in the first place is to enable productivity and reuse existing solutions for complex tasks. But there are some downsides, specifically inherent to the NPM package ecosystem. Let me explain. Today, whether you are just starting out to learn web development or maintaining an existing application, you will typically start with this command, npm install. For example, with the recommended way to start a React application, that is with create React app, we end up with over 1,800 packages as indirect dependencies from the direct 7 project dependencies. Also, lots of warnings that cause warning fatigue and often are ignored, and also some vulnerabilities. That's a lot for a start. To understand what's going on here, let's look at the dependency graph of another popular but complex project. On this tool, anvaka.com, you can see it is massive. It is highly interconnected. This is just one package example. Studies have estimated that the average dependency tree depth for an NPM dependency is over 4, higher than any other package ecosystem. And each of these dots potentially have their own development life cycles, breaking changes, vulnerabilities, etc. This is compounded by the fact that we have an exponentially growing package ecosystem that is approaching 2 million packages, and the fact that a significant portion of these are either abandoned, outdated, or unmaintained. Also, often, we don't see backports of fixes into older major versions, except maybe the popular ones, meaning we are highly encouraged to only use the latest versions and have to deal with breaking changes. Which brings me to the main point. So, over time, this can lead to a higher maintenance effort. Even with automation in place, developers need to dedicate focus and effort and time to fix when anything breaks. And every couple of years, it might even be more economical to rewrite web applications partially or from scratch. Dependencies do solve complex tasks and often can experiment and push boundaries faster than the standards-driven web platform can. But a lot of these tasks have been addressed by browser implementations today. We can have reusable components with encapsulated styles with custom elements and the shadow DOM. Bundling resources might not be necessary anymore with HTTP2, which can fetch resources in parallel. Also, for example, manipulating and querying the DOM was not as easy 2 decades ago, which jQuery solved for a long time. Speaking of jQuery, this year we saw the peak of jQuery, where its usage is finally on a downward trend on the top 1 million websites after 21 years in use. Even though the handy JavaScript primer you might not need jQuery.com exists since 7 years. To the question whether the platform has caught up with some things the library solve for us. It seems especially promising since all of the most used browsers support custom elements. Internet Explorer is finally deprecated. Safari has some limitations, but only regarding extending built-in elements. So our goals for this experiment is to try using the platform without external code dependencies. That means no build dependencies, no runtime dependencies, only the browser and the static HTTP2 web server like Nginx, Apache, or even GitHub Pages. Most importantly, don't try to create the next unmaintained framework. So the example application we are trying to explore is a simple to-do application. Maybe you may recognize the style of it. You can add to-dos, filter to-dos, toggle to-dos, etc. Our to-do item here extends from the native HTML element and uses the shadow DOM for style encapsulation. Also, it provides the common lifecycle methods of a custom element. Attribute change callback, connect the callback, disconnect the callback. You can learn more about all these on the excellent resources like Google's Web Fundamentals, Building Components, which also focuses on JavaScript without dependencies. Once we start using this custom element, with just a module script tag in the HTML, we notice a very refreshing experience, the buildless experience. With HTTP2 protocol for reusing connections, fetching these small pieces of code in parallel is extremely fast. Also, custom elements are not components. They are native HTML elements. And interacting with them on the DOM level can feel really nice. They react differently depending on where they are in the DOM. The DOM doesn't show a massive div soup to the developer, and no browser extensions are needed. The inspector tools is fully capable of displaying and handling them. We can directly append the custom elements to the DOM, and it would work as expected. Also, toggling the item via JavaScript properties is directly reflected on the DOM. One thing that seems very hard without any dependencies or Node.js runtime environment is unit testing and code coverage. But we can get assistance from the browser itself. Chromium-based browsers provide a coverage inspector. The question is, how can we access this programmatically for automation? Enter the Chrome debugger protocol, the underlying mechanism that Puppeteer and Lighthouse use for automated website testing. This protocol is a WebSocket-based protocol and actually supports taking precise coverage of the JavaScript and CSS files used. Firefox also supports a subset of the CDP, but unfortunately not coverage information. Okay, this one took some time to figure out, but we can directly interface with the WebSocket protocol, with the WebSocket shell utility. With creating a FIFO pipe, we are then able to send individual messages into an open WebSocket connection in a shell script, and wait in between these individual messages for the browser to do its task. Equipped with this information, we can now measure unit test coverage of a unit test running in the browser with only these 4 messages. For example, we can use it in a GitHub action, transforming the Chrome debugger protocol coverage format for a coverage reporter service like SonarQube. But after all this exploration, the rabbit hole goes deep. Are zero dependencies practical? Can we achieve the goal of decreasing development costs over time? I would say it is somewhat possible, but the effort can be really high, depending on what you're trying to achieve, like quality control with unit tests and coverage information, and the things we are used to, like state management, data binding, rendering and templating. Those are dearly missed. So maybe not 100% practical in the real world yet. Nonetheless, the buildless experience is really standing out for me. Wait, not all is lost. There are some awesome projects out there, like modernweb.dev, which pitches this issue exactly perfectly. And it is about low complexity, built on web standards, and lightweight. They emphasize writing code that is close to what actually runs in the browser, reducing abstractions and complexity. I highly recommend visiting these projects. And that brings me to my conclusion. That is maybe the sweet spot. While the zero dependencies might be an unrealistic goal to achieve, reducing the dependency footprint and relying on high quality packages is certainly beneficial over the long run for development costs. And thankfully, there are also many services available for monitoring package health. For example, the excellent Sneak Advisor, not only tracking security issues, but also the quality of the package. The metrics might vary between each of those tools, so it is important to realize what you're looking for, especially maybe going one slide back. Maintained but stable dependencies, fewer dependencies, dependencies with shallow dependency graphs, where effects are not compounded. So, thank you. Check out the experiment source code. I hope you learned something today, and thank you for your attention.
Thank you, Tom, for your presentation and for sharing with us all your rabbit holes which you encountered and the sweet spots which you found. I'm taking a quick look at the chat and the Q&A session. So Michael says, Tom for president of the universe. maybe after the presentation. Also, Michael is asking, how do we balance the just because we can doesn't mean we should debate? And will team size need to grow if we aren't outsourcing expertise to the open source or dedicated services?
That is an excellent question. Let me get my screen in order. That is exactly what this presentation also tries to address. There are two extremes. Zero dependencies is an extreme that will take a lot of effort. Outsourcing all the dependencies to the NPM ecosystem, it depends. It depends what is the quality of these packages you are using. So if you're using massive interconnected packages that compound these effects, maybe we should reduce them. So it is a middle ground, a sweet spot, but generally I think we should aim to reduce our dependency footprint and actually inspect the quality of what we're using.
Okay, so we have one more question. Jeremy is asking, first, nice talk. Did you try to adopt this stack to large code bases with multiple developers?
No, that is something that is probably also outside of the easy effort. Like this is a like how do you do versioning, for example? You will still need some kind of package ecosystem to evolve your code in some ways. So that is another reason why zero dependencies is a utopian goal that we should maybe aim for to take control over the code, but to a limit.
Okay, there are no more questions. Is for wait, let me check. There might be one. So what's the result of the experiment? Are you gonna go for it at Doodle?
There is another consideration to be made. We saw also design systems that are geared for the web, or design systems that are maybe also geared for native applications. And this is a boundary that custom elements will not be able to address. So I would say we will try to explore it in terms of does it make sense? But right now, I think it doesn't make sense. That is the result of this experiment. But it was an interesting learning experience. That is definitely the case.